So today we are continuing with algebra and we're going to be looking at solving equations today. So let's look at an example first. When we speak about solving equations, we're essentially trying to figure out what this letter x represents. Okay, so it's going to represent a number. So this equation means 2 times x plus 4 is going to be equal to 12. So we need to try and figure out what x actually is. And there's a few steps we're going to take to get to it. So we're essentially wanting to get x on its own. If you imagine covering up that 2x and think about on this side of the equation, what is stopping us from having 2x on its own? Well, we've got a plus 4 here. We're trying to get rid of this plus 4. And what's the opposite of adding 4? Well, it's subtracting 4. And when we're dealing with equations, we've got an equal sign here. We need to sort of think of our equations as a balancing scale. Whatever you do to one side, you need to do to the other. Okay, so we're going to subtract 4 from each side. So no matter what the operation is, if you do it to one side, you have to do it to the other. So we're going to take away 4 from each side. So plus 4, take away 4, essentially cancel themselves out. Then 12, take away 4, we'll be left with 8. So we didn't touch our 2x. So 2x equals 8. And remember in algebra, if you've got two terms, so 2 and x, or two letters side by side with nothing in between, that means multiply. So this means 2 times something equals 8. You might already be able to work it out, but we need to think about what process and steps are we actually taking here. If you now cover up the x, what's stopping us from having x on its own? Well, we've got to multiply by 2. So we need to essentially do the opposite, which is dividing by 2. And like the first step, we need to do this to both sides. Okay, so we're going to divide 2 on both sides of the equation. So 2x divided by 2 will just give you x is what we're after. And then 8 divided by 2 is 4. So we've now got x on its own, so x is equal to 4, and that's your final answer. And you can always just double check, make sure it's actually correct. If we were to think of x as 4, this would be 2 times 4, which is 8, add 4 gives us 12, so we know we've got the right answer. So following this example, okay, I would like you to have a go at this question. Okay, so use this example here to help you. Make sure you've got a copy down as well. So pause the video here and try to calculate and solve the equation for x. Okay, let's go through the answer. So if you cover up the 8x, okay, so the 8 is stuck to the x. If you cover that up, what's stopping us from having 8x on its own? Well, we've got plus 2 here, so we're going to do essentially the opposite, but we're going to do it to both sides. So we're going to take away 2 from both sides. So plus 2 take away 2, essentially cancelling themselves out. Then 50 take away 2 is 48, so we're left with 8x equals 48. Then covering up the x, we've got an 8 there. That's stopping us from having x on its own, so we're going to divide both sides by 8. So divide both sides by 8 to get x equals 6. So well done if you got that question. Now let's look at a second example. Okay, this time slightly different. We've got a negative in here. So we've got 3m subtract 7 equals 11. So we need to get m on its own. So if I'm going to cover up m and whatever it's joined to, I'm going to cover that up and say, well, what have I got that's stopping us from having 3m on its own? I've got to subtract 7. And we want to cancel this out. So what's the opposite of subtracting 7? Well, we're going to add 7 to both sides. So if we add 7 to both sides, we're essentially cancelling those out, just to be left with 3m on this side. And then 11 add 7 gives us 18. Covering up the m, we've got a 3 there that's stopping us from having m on its own. So we're going to divide both sides by 3 to get m equals 6. So again, the same steps as before, but now we've got to subtract and we need to think about how do we make negative 7 0? Well, we need to add 7, and whatever you do to one side, you have to do to the other. Okay, make sure you've got that example copied down, and once you have that, can you please try this question on your own? Okay, let's go through the answer to this one. Hopefully you've unpaused. Covering up the 7y, Okay, we've got a subtract 12 there that's stopping us from having 7y on its own. So we're going to do the opposite of that, which is adding 12. And we're going to add 12 to both sides, making this 0 just to be left with 7y. And then 9 add 12 will give us 21. And then covering up the y, because we're wanting that on its own, we have 7 that's stopping us from having y on its own. So we're going to divide both sides by 7 to get y equals 3. Again, really well done if you got that correct. Okay, another example. This time we have two terms that have got a letter in it. Okay, when we're still wanting to get x on its own, but we need everything with an x on this side of the equation, so on the left hand side, and then we just want to be left with numbers on this side. Okay, for now. So if we've got something with an x term in it, we're wanting to get rid of it from this side, the right hand side of the equation. So how do we get rid of a 2x? Well, we're going to subtract 2x from both sides. Okay, so 2x, take away 2x, and you have to do it to both sides. So we'll be left with 4x, take away 2x, it's just 2x here, and we'll be left with 12. Okay, so we're trying to get rid of all the terms that have got x in it. We can take away 2x from this side to cancel it out, but whatever we do to one side, we have to do to the other. So take away 2x to be left with 2x equals 12. Covering up the x, divide both sides by 2 to get x equals 6. Okay, we can take whole terms away as long as it's valid, you know. So 2x equals 0, we would have to take away 2x itself. Whatever you do one side, you have to do to the other. So make sure you've got that example copied down. And it's your turn again. Pause the video here and give this one a try, using the example to help you. Okay, so we've got 5x equals 3x plus 16. We've got a 3x on this side of the equation, the right hand side. We don't want it there, so we need to get rid of it. So we're going to subtract 3x from both sides, which is going to cancel the 3x out here. And then 5x, take away 3x, we'll be left with 2x equals 16. We've not touched the 16. And then covering up the x, we need to then divide by 2. Both sides divided by 2 to get x equals 8. Great stuff if you got that one correct. Okay, 2 more examples to go. So example 4. We've got 7y equals 3y subtract 8. Okay, it looks very similar to the previous question, but we've just got a negative on the end here. Okay, but same process as before. We've got a 3y here, we've got a y term. We don't want it on the right hand side of the equation. So we're going to subtract 3y from both sides. So 3y, take away 3y, we're cancelling that out. And then 7y subtract 3y, we'll be left with 4y. And be careful because on the right hand side of the equation, we are left with negative 8. Okay, whatever is in front of that sign must be left with it. Okay, so we're being left with a negative on this side. And if we're covering up the y, we need to divide both sides by 4. Of course, we can divide a negative. That's absolutely fine. So 4y divided by 4, we're just left with y. And then negative 8 divided by 4, we'll be left with negative 2. So x equals negative 2. Oh, x doesn't equal negative 2. Y equals negative 2. So that should say y. Okay, make sure you've got that example copied down as always. And your turn again. Pause in the video here and give this one a try for yourself. Okay, let's go through the answer now. So we have an x term on the right hand side of the equation. We do not want it there, so we're going to take it away from both sides. 4x subtract 4x, we'll cancel each other out. 9x subtract 4x, we'll be left with 5x equals negative 35, okay, because there's a negative in front of that sign, that number there. So then to get x on its own, we're going to divide both sides by 5 to get x equals negative 7. Okay, again, excellent if you got that one correct. Right, let's move on to our last example. Okay, each one getting progressively more difficult and adding a little step in each time. So we have x on this side and an x on this side. We've also got individual letters on both sides. We want everything, we want only x's on our left hand side of the equation and only numbers on the right hand side of the equation. So the first thing we're going to do is we're going to get rid of this -5. Okay, we only want x's on the left hand side of the equation. So like the first couple of examples, we've got a -5 here. To make this equal to 0, we need to add 5 to both sides. And whatever you do to one side, you have to do to the other. So that'll leave us with 8x equals 2x plus 42. Okay, we cannot add 5 to 2x, we're adding 5 to the 37. Okay. So now this looks very similar to example 3. We've got a 2x on the right hand side. We do not want any x values on the right hand side of the equation, so we're going to take 2x away from both sides. So 2x take away 2x, cancel each other out. 8x take away 2x, we'll be left with 6x equals 42. And then covering up the x, what's stopping us from having x on its own? Well, we've got times by 6, so we need to do the opposite to both sides, which is divide by 6. Then x equals 7. Okay, so we've got an extra step in there, but we're just bringing everything from the previous examples together with this question. Obviously, if this was a +5, we would take away 5 from both sides, so we're just applying the skills of the previous examples to what we have here. So again, as always, make sure you've got this example copied down, and your turn. Pause the video here and give this one a try. Okay, so we've got 9y take away 2 equals y plus 30. We are first going to get rid of this -2 here, and we're going to add 2 to both sides. That will leave us with 9y equals y plus 32, because we're adding the 2 onto the 30. Remember, in algebra, if you've just got a letter on its own, that means 1y. Okay, so we've got 1y on the right-hand side of the equation. We do not want it there, so we're going to take it away from both sides. Be very, very careful here, because this is 9y take away 1y. Okay, and mistake that a lot of people make is they just take away the y from that and are left with 9. Okay, that is not correct. It's 9y take away 1y, you'd be left with 8y equals 32. Cover up the y, we've got 8 that's stopping us from having it on its own, so we're going to divide both sides by 8 to get y equals 4. So that one was really tricky, so really, really well done if you got that correct.